Right, let's take a look at this problem. Implement trie. So a trie is a prefix tree. Um, tree that is a tree data structure used efficiently to store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. So I have to implement the constructor and few functions, and yeah. So let's get started. The first thing that in a trie I require is the trie node. So I just create a trie node like this, and I have to initialize it like so. And for so a trie node has has children dictionary and if it is the end word or not. So self-dot children, and we just have maybe default dictionary of trie node and the self a boolean, which is like end of word. It represents something like that. And then from collections, we import the default dictionary. So we just that will be enough, and then we need a root here, which will be trie node. And then when we are inserting, we basically take the root and create a current pointer that is pointing to the root. And then for every character in Word, we have to create a trie node just below it. What I mean by below it is that we just put it in the children dictionary of the current node. So the current, okay. So we have to create it. So since this is default dictionary, we can immediately use like current that children. We can create it like this, and we just put it like that, and we create a trie node, doing this because we have default dictionary, and this will return us the new dictionary, and we will just assign it to a current because that will become our new current. We want to go below in each step. We want to go down in each step, and when we do this, it's yeah. But the important thing here is to check. Okay, do I have to check here? So I have current children like that. Okay, for now, should I assume that it's working as expected? Oh, all right. One last thing is that at the end, current end of word should be true. I think this is correct. Just yeah, I should probably move on, assuming that it is correct. So in a search, it is similar idea. First, we have to create a pointer to the root to use it while we're searching. So we search every character in a word again, one by one, and every time we check. So if we check it, if the character C is in current the children, if not, we have to return false. Otherwise, we return true. But I guess, yeah, if string word is in trie. Okay, let me check one thing. So we search this and this is true. We search at is false. So it should be, the last one should be empty. So if, so return, yeah, I basically have to return the current dot end words, because if it is not end of the word, we should just return false. If it is, we just return that. So here we just go below, go down, and then try. And how do we do that? Is that we change the current to current that children see. We just go down like that. And it says in this function we basically look if there is a way to, if it is, it exists. So, right. So when we search, we insert apple. Yeah, we basically in this one we basically do this same thing, but we return false. In the end, we just return true. I think this is basically it. Maybe I can run it. It says prefix. Okay. Right. It looks like it's working. Maybe submit it. Right. It works, which is great. I'm gonna just compare for you one of the discussion answers with this, and then see if there's a really better way to do it. So for now, I'm just gonna stop. Alright, so I just checked. There is no significant difference, only that it gets the current value. It gets this value in some like solutions that they are getting this put it into a variable, and then checking if it is none or not, and then going on like that. So yeah, but basically, I think this is the structure of a trie, prefix tree. So, right, yeah, that's basically it.